Okay, so quick review of naming rules. All right, so we got ionic compounds. First off, how do I know if it's ionic? Metal and non-metal. All right. Okay. When I'm writing the formula, or sorry, writing the name, I write which one first? Okay, metal first, non-metal second. Okay, what do I do with the non-metal's name? Right, okay, and then I add "ide" to that name. Okay, when I'm naming, I've got a metal with more than one possible charge. In the name, I have to put? Right, I have to put in Roman numerals for the multivalent, we call them metals. Okay, quick review on how we tell which Roman numeral to put in there. Let's say we're dealing with something like that. Okay, I've got cobalt with nitrogen. Cobalt has more than one possible charge. It can be 2 or 3. Hopefully I picked that right. Yep, 2 or 3. Okay, nitrogen is always, however, -3. All right, so I always look to the non-metal because I know it's only going to have one possible charge. When all is said and done, the net overall charge of this compound has to be 0. All right, 2 times -3 is -6. So there are 6 negative charges. That means there have to be 6 positive charges. So the charge on cobalt will be 2, okay? Because 6 divided by 3 is +2. So then we write cobalt, Roman numeral 2, nitride. I think I said nitrate. I shouldn't have said that. Nitride. Okay? That's a D, not a T. All right. Is that making sense? Okay, I'm writing the formula. How do I figure out what the numbers should be? I drop and swap. Okay, for the formulae. So let's say example, I've got hydrogen sulfate. Throw in a polyatomic ion on top of that. Okay, so first thing I do is write down the formula for each one. Hydrogen is a +1. Sulfate, SO4, is a -2, I think. You can double check. Pretty sure it's... Okay, yeah? All right, now I drop and swap, same as I always do. So the 2 comes here, okay? The 1 goes there. Since I don't have to write a 1, I don't need to put sulfate in brackets. If it was anything other than a 1, then it would need brackets. Otherwise, it would be SO4 and another number right after that, and it would look silly. Okay? Everybody ringing a bell? Okay. All right, for the molecular ones. Molecular are easier because you don't have all these extra rules. Molecular compound are made of 2 nonmetals. Okay, when I'm naming, what do I use? Prefixes. So we use prefixes to denote numbers. All right. So let's say we had to write the name of this stuff. I don't know if that really exists. I'm just making stuff up. Dinitrogen triphosphide. Okay, and writing the formulas for molecular compounds is ridiculously easy because we just look at the prefixes and know what numbers to write. Okay, so I mean in this case, if I was looking at dinitrogen triphosphide, I would know that di means 2, so I'd go N2, triphosphide P3. All right, ringing a bell for everybody. Okay, so the key here though, okay, the thing that people mess up is when they're actually doing a worksheet or a question on a quiz or something like that is they just seem to forget to identify whether it's ionic or molecular, which is obviously the first step, okay, most important step in naming something correctly, and they just pick whichever rules seem to appeal to them. Okay, that's actually, believe it or not, the mistake I see most often is molecular rules applied to ionic, ionic rules applied to molecular for unknown reasons. I think most of the time it happens with polyatomic ions because they just look different and people don't really know what to do. They forget that those are ionic compounds. Okay, so keep that in mind, okay, when we are working on those. Questions on that? All of them except for ammonium, which is NH4. It's the second one from the top on the first column there. That's the only one with a positive charge. So it's the only one that behaves as a metal. All the others behave as nonmetals because they're negatively charged. Okay? Everyone follow me there. Now, that said, is it possible to have a compound that has two polyatomic ions in it? Probably, as long as the metal is ammonium, because it's the only one that has a positive charge. Okay? And you have to have an ionic compound that comes out to 0. So you're never going to have something like silicate hydrogen sulfate, because that's two negative things. They won't go together. All right? So yes, it's possible to have a compound like this. And let's say it's, this is actually one that we will talk about later this week, because it's going to be one of our unknown compounds in our lab that we will do next week. Okay, ammonium nitrate. Right? So if I'm going to write the formula for this, I look up ammonium on my periodic table. Ammonium is NH4, and it has a single positive charge. Okay, and nitrate is NO3. It has a single negative charge. Drop and swap, they're both ones. So I have NH4, NO3. Okay? So it's possible you can have two polyatomic ions, but one of them will have to be ammonium because it's the only one that's positively charged. Okay? So more often than not, it'll be a metal with one of the other polyatomic ions. Okay? Everybody with me there? Okay? Incidentally, this stuff, if you've ever used a cold pack, one of those ones where you pop the little water ballast that's inside, the little bladder, not ballast, little water bladder that's inside, you ever pop one of those and then shake it up, it gets cold. Okay, the stuff that you can hear shaking in there, the crystals, that's ammonium nitrate. When it reacts with water, it gets cold. Okay, so it comes in pretty handy actually. It's quite soluble in water. Okay, the crystals are actually little tiny kind of off-white, almost a hint of pink little spheres. Okay, that's actually what they look like. So it's kind of a strange ionic compound. It's got circular crystals. Okay, it's weird. All right, any other questions on that? That was a good one because we didn't really talk about that last week. All right, what I'm going to do is hand out some worksheets to you. I want you to just practice this stuff. Some of them are writing, they give you the name, you have to write the formula. Some of them are, here's the formula, write the name. Okay, the keys for these are on my website. Here's how I want you to use the keys. Don't just open up the key on your phone and start copying down the answers on the worksheet. I'm not taking these in for marks, and that's not going to help you in the end. Okay? What I want you to use the key for is to check that you're doing it right. So, how many should you do before you check them? Like 5. Yeah, I'm thinking do 5 because I had some people who did like the whole sheet and then checked their work and they were all wrong. Okay, now here's what they've done. Not only have they gotten them all wrong, but they've practiced doing it wrong like 35 or 40 times. That's a hard habit to break. Okay, so we don't want to do that. Try 5, check the key, see if you're doing it right. If you're making a similar mistake each time, call me over. Okay, and I can give you a hand with that. Here's where the keys are at. Okay, so you probably will want your phone out. You can have your phone out just so you can have this open and you can be checking as you go. So you go to my website and you go to Science 10 stuff and you go to Chemistry. And down near the bottom of the Chemistry folder, it's a ways down, naming key 1, naming key 2, naming key 3. I don't know if they go in the same order that you'll get the sheets or not, but I mean, you'll be able to look at it and tell whether it's the sheet you're working on. Okay, that's where you need to go. All right, look at those, have them open, and you can just check your work as you go along.